Okay, this is a study guide for 3.1 and 3.2. Okay, question 1 asks where the coordinates are for B. The coordinates, it's right here. So you go to the left 1, 2, 3. So that'll be your x coordinate, which is -3 because it's to the left. And then up 2, 3, 4. So your y coordinate is 4. So it is -3, 4. Okay, number 2 wants to know what quadrant it is. So we know the quadrants go 1, 2, 3, 4. So if we did 9, -3, we'd go 9 this way, and then -3 would put us here. So we're going to be in quadrant 4. Okay, the same thing. 1, 2, 3, 4. Remember, they make a C. This is the x-axis, this is the y-axis. So they want us to go -6, 0, which would be 1, 2, 3, 4, 5, 6. 0 would put us right here, which is the x-axis, because you're not actually in a quadrant. Okay. Okay, number 4 wants us to determine whether the ordered pair is a solution of a given equation. So you're going to plug in x and y. So it becomes 5 times -2 plus 5 times 1 equals -5. 5 times -2 is -10 plus 5 times 1 is 5 equals -5. -10 plus 5 is -5. So since you end up with a true statement, yes, it is a solution. Okay, same situation here. You're going to plug in x and y. So you get 6 is equal to the square root of 169 minus 7. The square root of 169 is 13. 6 is equal to 13 minus 7 is 6. So since it is a true statement, yes, it is a solution. Okay, same situation here. You're going to plug in x and y. So 0 is equal to the cube root of 9 minus 3. 0 is equal to, the cube root of 9 is like 2.03 and some change, minus 3. 0 is not equal to 2.03 minus 3, so no, it is not a solution. Okay, determine whether the equation is linear or not. So you want to ask yourself 3 questions. 1, is x being raised to a power greater than 0 or greater than 1? No, it's not. 2, is x an absolute value? Yes, it is. So this is not linear. And it is because x is an absolute value. Okay, same situation here. Ask yourself the first question, is x being raised to a power greater than 1? Yes, it is. So this is also non-linear. All right, same situation here. Ask yourself the questions. Is x being raised to a power greater than 1? No. Is x an absolute value? No. Is x in the denominator? No. Is the equation in the form y equals mx plus b? Yes. So therefore it is linear. Okay, now they want us to graph the equation. So the first thing you're going to do is put it in slope-intercept form by isolating your y. And let me make sure, I feel like let me make sure that's the right equation. Yeah, it was, hold on one second. It was actually -9x, not positive 9x. So this was -9x minus y equals -4. So you're actually going to add 9x to both sides. So you have -y is equal to 9x minus 4. And then you're going to divide -1 from all the pieces. So you get y equals -9x plus 4. So you have your x and y axis. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. So your slope is -9 over 1. And your y-intercept is 0, 4. So the first thing I'm going to do is plot my y-intercept, which is here. Then you're going to rise over run. So it seems weird, but you're going to rise down. So you're going to go down 9. So you go 1, 2, 3, 4, 5, 6, 7, 8, 9, and you go over 1. So end up here. Just connect your 2 points. And that's your graph. Okay, the y value is, so y equals 10 decreased by 9 times the x value. It has to be in this order. Think about your bank account decreased by $9. So you would subtract 9 from your bank account. So 10 decreased by 9x is 10 minus 9x. All right, graph the equation y equals x plus 3. All right, you have 2 options on how you can do this. You can either plot the vertex, which is your value here, written as your x value, but change the sign, and then make your y value 0. So when you go to graph it, you go right here, 3, 0. If that's not enough information for your graph, you're going to make a table. And you're going to choose some values for x. And then plug them in. Absolute value of negative 2 plus 3 gives you the absolute value of 1, which is just 1. And then you have the absolute value of negative 1 plus 3 is the absolute value of 2, which is just 2. Then you have the absolute value of 0 plus 3, which is just 3. The absolute value of 1 plus 3, which is the absolute value of 4, which is just 4. The absolute value of 2 plus 3, which is the absolute value of 5, which is just 5. And then you can go ahead and make another column if you want and get your ordered pairs, which would be negative 2, 1, negative 1, 2, 0, 3, 1, 4, and 2, 5. So you would have negative 2, 1, negative 1, 2, 0, 3, 1, 4, and 2, 5, which gives you this line here. But because we know that it's an absolute value graph, you know it's going to be a V, so the rest of your graph is there. All right, find the domain and range. So your domain is all your x values. And remember, we don't repeat. And then your range is all your y values. Okay, number 14 says, find the domain and range and then determine whether it's a function. So your domain is 11, 2, 3. And then your range is negative 2, negative 1, 0, 1, and 3. And then when you go to decide if it's a function or not, you list them all out. And you have 11, 2, and 3. And you have negative 2, negative 1, 0, excuse me. One and 3, and then we've got 11 goes to negative 2, and 2 goes to negative 1, and 2 goes to 0, and 3 goes to 1, and 11 goes to 3. So we have an issue here and an issue here. You have x going to You have 11 going to two different numbers and 2 going to two different numbers. So this is not a function. Susie the floozy. Can't have it. Okay? Determine whether the relation gives a function. When you graph this, it's one of our common graphs. Remember, this is the squiggle. Okay? You can do the vertical line test. And every time you do it, it only hits it one time. So this is a function. So we're okay. 16 is x equals y equals x squared. It should actually be, this should be squared. Now don't get confused and think that this, okay, this whole thing is wrong. It's actually x equals y squared. Remind me to yell at Miss Shipman. So if it was y equals x squared, it would be a function. But because the y is being squared, it is not a function. Okay, find the domain and range of the relation. Okay, so domain is how far left and how far right the graph goes. This graph goes this far left and this far right. So for the domain, it would be bracket -9 to 9. Okay? And your range is how far down and how far up the graph goes. So it goes down to -5 and up, I'm sorry, just getting -4. And up to 4. Now, is it a function? Let's draw some vertical lines. How many times am I hitting the graph? 2 times each. So no, it is not a function. Okay, so for 18, the domain is how far left and how far right does the graph go. So how far left is -1, and how far right is 1. And the range, how far up and how far down, is going to be -infinity to +infinity, because it's going to keep going forever. Vertical line test, nope, because we're going to hit it more than one time. So it is not a function. All right, all we're going to do for f of 6 is plug in 6 everywhere there's an x. So you end up with -6 over 2. So you end up with -3. Okay? If you have f of t is equal to 32t, then f of 11 would be 32 times 11. So f of 11 is 352, and it's feet per second. Okay, that's it. You guys have a good day.